Okay, so the first thing I think is helpful in doing these problems is go ahead and write out the function and actually draw it from 0 to 2. So it's just x squared. We know 0 squared is 0, 1 squared is 1, 2 squared is 2, and then I just sketched the curve, and I sketched it here as well. Notice here, this one's asking for right endpoints, and this one's asking for left endpoints. So when I make my rectangles, we only want 4 total rectangles, and I think it's kind of easier if you know you're starting with right endpoints, start at the right side, and you're going to go all the way up to that point, and then you're going to draw a rectangle straight over like this. So now this endpoint is at the right, this rectangle. So start at the right, 1, 2, 3, and then here's my 4th rectangle. Now to calculate the area of a rectangle, you guys know it's just base times height. Well, the base of all of these is called change in x. The change in x on all of these is just a half of a unit. You guys can kind of see that. All those are just a half a unit. And then you got to think of how high the rectangle is. So if you would just type in, think of what that point is on the graph for 0.5, that would be 0.5 squared, which is 0.25. That would be the height of this rectangle. And then we know that at 1, the height of this is 1 squared, so this is 1. At 1.5 is 2, oh, it's 2.25, is making sure. 1.5 squared is, 2.25. I'll write that here. And then we know that 2 squared, the height of this rectangle, would be 4. So then all what we're interested in finding is the area of all these rectangles added together. Okay, that's where that summation notation came from, because you're going to add up all 4 rectangles. So the area of this rectangle is 0.25 times 0.5, 0.125 plus 1 times 1 is 1, plus 1.5, oh, no. I take that back. The base of all these are 0.5. I said that earlier, sorry. So it'd be 0.5 times 1, which is 0.5. Then we do 0.5 times 2.25. 0.5 times 2.25 is 1.125. And then finally, 4 times 0.5 we know is 2. So then you add up all those numbers and you get, and you guys can tell by the picture, is this an overestimate or an underestimate? Obviously, these are a lot higher than what the curve would be, so this is going to be an overestimate. There, now we can see overestimate. All right, let's do the same thing. This is going to be a little quicker for what if we're going to use the left endpoint. So this time I'm going to start at the left. Notice if my first endpoint is at the left, that's at 0, 0. That's the completely flat rectangle. The area of that rectangle is 0 times 0.5, which is 0. Okay, this one, if we drew it to the right, notice the height is happening at 0.5, you can cheat and use what you already knew over here. This rectangle, these 2 rectangles I'm pointing at are the same rectangle. So this answer was 0.125. And you can kind of keep repeating that. Then the next one was 1. No, the next one was 0.5. I messed up last time too. And then this one would be the 2.25. So notice we don't use the 4 at all because this one's not drawn. So here for our endpoint was at the right side. Or left side, sorry. I drew that one wrong. We draw this and then left side like this. Okay. And then you would add up all those numbers, and that's 1.75, and that's definitely an underestimate. So all we know is that the true area is going to lie somewhere between these values. So that's how you do page 5. So I think you guys should be good to do page 6. It's very, very similar. So try to figure out page 6 on your own. You can definitely ask me for help if you want.